Hello students, welcome back to today's video session class. This is our third video class for chapter number 15, that is circles. In the last video class I have explained few questions from exercise 15.1 and I've also explained you two questions in your doubt clearing class, online doubt clearing class. Today I'm going to explain three more important questions from this exercise. Remember, the questions that I am explaining you in these videos are very important in your exam point of view. So take it seriously and try to solve it at your home. And if you get any doubts after that, also you can text me or you can ask me in your online class. Okay. Now, in the today's first question is question number 14 that I have chosen. The question is that the length of common chords of two intersecting circles is 30 centimeter, and if the radii of the two circles is 25 centimeter and 17 centimeter, find the distance between their centers. Means see the question figure that will make you understand the question. First of all, here this question is given. There are two intersecting circles. The circles intersects at the point A and B, and the common chord, the line joining the AB is the common chord to these both circles, whose length is 30 centimeters given. So the chord length of chord AB is given 30 centimeter. Okay. After that, the radii of these two circles are also different. So radius of the first circle is OA, that is 25 centimeter, and the second circle, that is O dash A, is 17 centimeter. Now you have to find the distance between this O dash, means distance between the two centers of this circle. Now as you know, so AB is the chord and O dash are the straight line which is perpendicular to this line AB and also bisects the line AB, because you know from the theorem that if a line drawn perpendicular to the chord bisects the chord. So if you take this point M, O dash M is perpendicular to AB and OM is also perpendicular to AB, and also if they bisect, this point M bisects the line AB at midpoint. So we can have written OO dash is perpendicular bisector of AB at M. So AM is equal to MB. So what is the measure of M is equal to 30 by 2, that is equal to 15 centimeters. Means this portion AM is 15 and BM is also 15. Now I have taken the triangle here. Two times I have to take the triangle. First of all, so it is a perpendicular here. You can draw the perpendicular also. So in the right angle triangle OMA, or you can say OAM triangle. See, this is OA is the hypotenuse and these two are the other sides. So OA square is equal to OM square plus OAM square by Pythagoras. You can write here by Pythagoras theorem. Okay. So OA is 25. So 25 square is equal to OM. You have to find OM, and AB we have got 15. So 15 square. So 25 square is 625 is equal to OM square plus 15 square is 225. So ultimately OM square is equal to 625 minus 225, that is equal to 400. It is 5. Okay, it is 5. Now OM equals to square root of 400, that is equal to 20 centimeter. We have got this OM equals to 20 centimeter. Now consider this triangle O dash AM. O dash AM. In this right angle triangle, Again, O dash is the hypotenuse, and these are the two other sides, AM and MO dash. So O dash A equals to AM square plus MO dash square. Now OM is here, so radius is given 17, so right here 17 square equals to 15 square plus MO dash. Now MO dash square is equal to, here I have to write the square. So 17 square is 289 minus 15 square is 225. When you subtract them, you get 64. So MO dash equals to root over 64, that equals to 8 centimeter. Now it is 8 centimeter. Now OM is 20 and O dash M is 8. So ultimately OO dash equals to OM plus MO dash, that is 20 plus 8 equals to 28 centimeter. So the distance between the center of these two circles is 28 centimeter. Now move to the next question. I will send the pic of this board to you in WhatsApp group. You can copy it from there also in your school classwork copy. Okay. Now question number 15. The line joining, what is the question here? The line joining the two chords of a circle passes through its center. Then you have to prove that chords are parallel to each other. So here in a circle, two chords are given. Both of these two chords are of equal length, and you have to prove that the line joining the midpoints of these two chords, if you take M is the midpoint of CD and N is the midpoint of AB, so we can say that the line joining the midpoints is M and N, straight line M and N is passes through this center of the circle. So you have to prove this O is the center, and you have to prove that this line AB is parallel to CD also. So for that I have taken the points what you have to prove. Since N is the midpoint of chord AB, that means ON is perpendicular to AB. That means ONB, or you can say ONA, whatever triangle you can angle you can take. This is ONA is 90 degree, because the line joining drawn from a center of a circle bisects the chord is also perpendicular to the chord. Theorem is there. Similarly, since M is the midpoint of CD, so the line joining OM to this point is perpendicular to CD and also okay. So again OMD is 90 degree. So OMD is 90 degree. Take it as 1 and 2. So from this 1 and 2 equations we seen that ONA, this angle is equal to OMD. So these two are both 90 degree. Since these two angles are also alternate interior angles, so by the property of parallel lines, if the alternate interior angles are equal, then the lines are always parallel to each other. So here the two alternate angles are equal. That means we can say chord AB is parallel to CD. So in this way you have to prove this question. Next question that I am going to explain you, that is question number 20, subpart B. Very important question. I have done some part of the question here. After that space is not there, so that's I have I have solved it here. I have given the star mark. You follow the star mark. Okay. Here you have to prove two things. First of all, you have to see the question. Here the question is given. A circle is there whose AB and CD are equal chords. These chords are equal. AB and CD are equal chords with center O. Now if you extend the chords AB and CD, they meet at the point E. Okay. Now you have to prove two things. First of all, you have to prove this AE, the secant AE equals to CE, and also BE equals to DE. So two things we have to prove here. So first of all, A equals to EC and BE equals to DE. To prove this question, first of all we have to do the construction somewhat. So first of construction that I have done is draw OM perpendicular to AB, draw OM perpendicular to AB, then draw ON perpendicular to CD, ON is perpendicular to CD, and also join the points O and E, center and this point you have to join them. Now you have to consider these two triangles first of all. In first triangle OME and ONE, what you can say that the line OE is common to both these triangles, and this is also the hypotenuse because these two are 90 degree. So the hypotenuse OE, that's OE equals to OE, common side. After that, by construction, these two angles are 90 degree. So OME plus ONE both are 90 degree also. And since the chords are AB and CD are equal chords, that means they are equidistant from the center. So from the theorem we can say that OM equals to ON also. So equal chords are equidistant from the center. Always write the theorem. Okay. After that, so you can see right angle one side and hypotenuse there. So by RHS congruency, OME is congruent to triangle ONE. That means we can write this ME equals to NE by CP/CT. Now, see, take it as 1. This ME and NE are equal, take them as 1. Now, since you have by construction you have drawn the OM is perpendicular to AB and ON is perpendicular to CD. So therefore we can say here, if a line drawn from a center of a circle is perpendicular to the chords, bisects the chord. So M and N are the midpoints of side AB and CD. So M and N are the midpoint of chords AB and CD respectively. So we can write MB is a half of AB and ND is also half of CD. So MB is a half of AD and ND is half of CD, and since AB and CD are equal chords, it's given, that means their halves are also equal. So we can write MB equals to ND since AB equals to CD. Take it as number 2. Now subtract this equation 2 from equation 1. What we will get? ME minus MB. So ME minus MB, that is equal to BE, and NE minus ND is equal to DE. So first one is proved. ME minus MB is equal to NE minus ND, that is equal to BE equals to DE. So number 2 equation is proved. B equals to D. Number 2 part of the question is proved. Now again consider this one as number 3 because we have to use it to prove the first one. Okay. Now come to this side. Space is not there, that's why I have solved this question, rest of the question here in this small box portion. You can see it here. Now AB is equal to CD, it's already given, you take as number 4. From this 4 and this 3 you add them. So we can say adding 3 and 4, what we get? AB plus BE and CD plus DE. So AB plus BE, that is equal to full AE, and CD plus DE is equal to full CD. So we have to prove that A equals to C. So ultimately we can write AB plus BE equals to CD plus DE. So in place equals AB plus BE is AE and CD plus DE is CE. So the number 1 is also proved. So in this way we have to prove this important question. So rest of the question you please try at your home. Then also if you get any doubts, please ask me. I hope you have understood the question that I have explained you today. I will send these question solutions in your WhatsApp group. Please go through the video also and do the sums properly and try to send your work on time. Okay, students. Hope you have understand what I have taught today in this video session. Thank you very much. Stay safe, stay healthy.